Hello guys, welcome back to Daily Coding. Today we are going to discuss a very important question. Kth largest element in an array. So how to find given value largest number. Here I will provide the logic and here we'll use the new concept. We have mean heap and max heap concept. Mean heap is the property. So let me just give a little bit brief about it. Mean heap. In mean heap, root element is always smallest element. So that is the property of mean heap. And in the max heap, root element will be always the largest element. Root is largest, and here mean heap root will be always smallest. And in the Java, it's implemented using the priority queue. I'll make separate video on the mean heap and max heap, but now we'll just use the concept of mean heap and then we'll try to solve our problem. So we already solved the problem of second largest element. So we know which we have to find which element, then we can define first and second, and then we can try to solve using normal for loop. But here it can't be possible. So we'll use the mean heap concept. So let's see what is the logic of that and how we are solving the problem. So here what we have to do, suppose here it's given the k element. So k equal to 2. So we have to define the mean heap. What is the strategy for that? We'll keep the mean heap size at most k. So if our mean heap value will be greater than the k size, we'll remove the value from the mean heap. And smallest element are always discarded by a pop. So if the size is greater than k value and then we just remove the smallest element and then we'll get the one by one the largest element behind the root element, and remaining k element are the largest so far. The root is the minimum of this k largest element. So which is the k largest element is the minimum of the root value. So here the logic is defined. So start with k largest element will, and then initially we will define the mean heap. Let me write how to write this mean heap. So here we have to define. So this is the mean heap, and if we have to define the max heap, we can just reverse this mean heap. So if we'll use here collection dot reverse order, then it will be behave like a max heap. Either we can use the comparator also and define it here, but now we are just using the mean heap and we'll iterate through array. So we have to iterate the array, and we will if num is not, we have to put num value, the array value, in the mean heap, and we have to check it if heap size is greater than k. So if heap size will be greater than k, in that case we'll pop from the smallest element from the mean heap, and then again we'll go with the next element, and till now when we reach the iterate array will be finished. Then our the last element will be the, we have to pop up and we'll get the kth largest element. So that is the logic for that. Let me explain how it will be look like. So suppose here First array value 3 will be go, and then 2 will be assigned here. And third element, so here we can see 2 is less than 3, so it will automatically min heap will be swap, and then value will be like this. So it will become 2 to 3. So internally heap will be swap the value. So min will be the always largest element, and then it will came here. So min heap will be work like a tree, and it should balance search tree, and here its value will become. Here it will again check this value. 2 is 1 is less than 2, so it will again swap the value, and now 1 will be assigned here, and 2 will be came here. And our logic will be also min heap size greater than k. Here k was defined, so we have to check if min dot size greater than k. So we have to just pull the element, and now size will become 3 to 2. So 1 will be removed. Okay. Then again this 2 will become here, and now we are going to add 5 values. So 2 is 5 is greater than 2, then it's okay. And will again size of the this heap will be the greater than k. In that case again it will be removed. So 2 will be also removed. Let me write it here. So now here the 5 value was there, and it will be also swapped. So uh, 2 will be removed, and in that case 3 value will be here, and 3 is less than 5, so this will be swap value, and now now 3 will come here, and 5 will be down, and we are adding the 6 value. 6 will come here, and it will check 6 is less than greater than 3, and then it's okay, and size will be heap will be greater than k, so this 3 will be removed, and now 6 will go here, so this is also removed, and here came 6, and then we have 5 value, and 5 is greater than 6, and 4 will came here. So 4 also it's came here, added in the loop. So 4 will be here, and 4 is less than 6. In that case, it will swap the value. It will swap the value, and now 4 came here on the root. 4 will be on the root. It came here, and 5 is still here. 5 and 6 will be here. And size of mean is greater than k, means greater than 2. In that case, 4 will be removed, and now we have remaining 6 and 5. So here we have value 6 and 5. 6, and then we have value 5. And now it will check 5 is less than 6. Then it will swap the value, and now our tree will become like this: 5 and 6. And now our loop will be completed. This array, all element of the array is iterated. In that case, we'll out of the loop, and then we just return heap dot peak values. Whatever the value on the peak, we have to return the value, and we'll get the result. So we'll, in the end of the, we have to return the value, and it will return the 5 value. So 5 will be the answer. So let's write the code, and we'll see how it's working like that. Here we define so here we define the mean heap, and now we are going to here we are using the enhanced for loop. You can use the normal for loop also, and we are going to, now we are started adding in the mean value. Mean dot add, and here we have to add, and we have to check now if mean dot size greater than k. If the size is greater than k, we have to pull from the mean. So we just need to pull, and then if loop will be completed, in that case we have to return mean dot peak. So peak will be always written, which is on the top, and it will be return the required result. Let me run the code. Here we can see all the test cases passed, and let me submit this also. And it's passed, all the test cases passed. Here we just use Min Heap. Here Min Heap, and then we are adding value in Min Heap, and if size will be greater than k, checking size greater than k, then here we have to remove the value, removing element, and in the end we are just returning the peak value. So I hope it's very clear, and let's see one more time the algo. So here we have to define largest element. We are defining the initialize empty bin heap, iterate through array. For each element, we are pushing in the heap. If heap size is greater than k, then we have to pop smallest element from the min heap, and again we have to iterate next element. And if it's again, we have to again push it, and we have to follow this approach till all the element will be finished. And in the end, we have to return the root of the min heap, the peak element, and it will be solve the problem. So here we have you learn the new concept, how to define the min heap in the Java, and then we are checking, uh, and we have to pull the value. So I hope it's very clear, and I hope you learned something new. And I'll make video on the min heap and other algo. So just separate video I'll create on that. So stay tuned with me, and please like and subscribe and share with your friends. Thanks for watching. Bye bye.